Okay, here are four shapes, each of which you're required to figure out what is a good formula I can use to calculate the remaining red in each of the four pictures. So if you want to try these, press pause and press unpause and see if you did okay. The first question gives us a shape that looks like this, and all the measurement we have is the side length of the square. So if I was to remove this white circle and say, what is the area of that red? The formula we would use for that is side squared. But from that square, we are missing a circle's area worth of red. So side squared removing the area of whatever that circle took away is what remains of the red. So the square take away the circle equals the remaining red. So the area of the circle, or the square, excuse me, is 10 squared, or 100 square meters. I won't put the meter squared, I'll just put 100. Take away the area of the circle, which is 3.14 for pi. Now, it appears that there's no measurements for the circle, but if this is 10, that 10 is also the diameter of the circle, which means the radius is 5. Okay, so the diameter is 10, then the radius is 5, so we're going to put 5 squared here, or 3.14 multiplied by 25, which is 78.5 square meters. So therefore, the area of the square, if nothing was cut out, would be 100. The area of the circle, which is what's missing from the square, is 78.5. So therefore, the area of the remaining red would be 21.5 square meters of red. Your second question gives us these what we call concentric circles. And since we're looking for the area of the red, if I was to ask you a simpler question and just remove this and said, what is the area of the red? That would be a circle whose diameter is 12 meters across. But I'm cut out part of this white. So if I asked you, what is the area of the red now? You would say it's the area of the large red circle, take away the area of the white circle, correct? That would be the area of the red in this one. But to that, we're going to add another circle. So really, what we have for a formula is a pretty complicated one. It's pi r squared for the large one, the largest. Take away pi r squared of the white, plus pi r squared for the middle red, the small red. And that would be our formula. It's actually three circles, the concentric circles. So the large circle has a diameter of 12. So it's going to be 3.14. And if the diameter is 12, what's the radius of that large one? 6. So the area of the large red circle, if nothing was cut out, would be pi r squared. But we are going to cut out the entire white circle. And I'm going to show you again. That entire white circle we're going to cut out. Okay? So that is going to become 3.14 multiplied by the, what's the diameter of that white circle? So what's the radius of that white? 4 squared. But we didn't cut out all of the white circle because we added back into it, this small red circle, which is going to be pi r squared, which is going to be 3.14. And what's the radius of that small one? 2 squared. So now we have the large red circle, take away the white circle, plus the small red circle. All of that should be the total red area in that shape. So we're then going to simplify this by going 3.14 multiplied by 6 squared. What's 6 squared? 36, not 12. Minus 3.14 multiplied by 4 squared, which is 16, plus 3.14 multiplied by 4. So once we have all this, we just need our calculator. What's 3.14? 3.14 times 36. It's 113.04. Take away 3.14 multiplied by 16. It's 50.24. Plus 3.14 times 4, which is 12.56. Okay, so the large red circle, take away the full white circle plus the additional red circle in the middle. Do all this on a calculator. So 113.04, take away 50.24, plus 12.56. Our final answer is 75.36. whatever unit squared. Okay, our next one, if we think about this formula, what would this be if I wanted to calculate the surface area of this? Base times height divided by 2. But how much is missing from that base times height divided by 2? A circle's worth. So technically it's a triangle, which is this. Take away a circle, which is this. So our formula will be base times height divided by 2, take away pi r squared. The base is 10, the height is 10 divided by 2. Take away 3.14 multiplied by the radius, which is 7 squared. Uh-oh, I just realized what's going to happen. I made a mistake. Yeah, I'm supposed to be the diameter. Oopsie daisy. Oopsie daisy. Okay, so 3.5 squared. Hopefully this works out okay. I don't even think it's going to work out still, is it? So when I work out this, it's going to become 50. Take away, I'm pretty sure I messed up, 3.5 squared is 12.25 multiplied by pi. Oh, I think we're okay. Yeah. Equals 38.465. And 50 take away 38.465 is 11.535. Assuming that the diameter was 7, and not like the boneheaded teacher who put a diameter of 14 for a side length of 10. Impossible to fit. Okay, your last question is this composite figure here, and it is rather complicated, so pay attention. So if I was to break it down into individual parts, and take this triangle out, and take this here, I would have a rectangle, and a half circle, and a triangle, right? When I put them back together, I could come up with an area for the red, and it would be length times width for the rectangle, plus, how would you do a semicircle? What would a formula be for that? Pi r squared divided by 2. Because if you want half of a circle, it'd be pi r squared divided by 2. So I'm going to put these back together, and your formula so far is length times width for the rectangle, plus pi r squared, but what we're going to do with that is we're going to cut it in half. I think we're good. We're good. Okay, so this is going to be the formula we use for this shape. Does everyone agree with that? A rectangle plus half a circle. Okay? And from that, when we calculate what that is, what are we going to take away from that? We're going to take away a triangle. So the formula you should have created for this is a length times width plus half of a circle, or half of a pi r squared, take away base times height divided by 2. Okay, what's the rectangle's length and width? It is 6 by 8. So we're going to put a 6 and an 8 here for the rectangle. The semicircle right here, this is going to be the tricky part. Let's see if we can do this. I'm going to bring it over here. And assuming that that's the radius, does anyone know how long that green line is? It's how long? It's 4. And we know that because if I was to bring this back over here, right? Since this whole thing is 10, and this is 6, then the remainder must be 4. So the radius is going to be 3.14 multiplied by the radius, which is 4 squared, divided by 2. And then my triangle, what's my base of my triangle? 6. What's the height of my triangle? 10 divided by 2. So when you substitute all the information in, that's what you get for numbers when you substitute in your formula. 48 is the area of the rectangle. 3.14 multiplied by 16 divided by 2 would be 3.14 times 8 if I get really smart. 3.14. I'm just going to multiply it by 8 because instead of multiplying it by 16 and divided by 2, I can just do that. 25.12. Take away, what's half of 60? 30. So therefore, when I grab my calculator and go, what's 48? Take away 25.12. Sorry, plus. That was supposed to be plus. Oopsie daisy. Okay, let's just clear this. 48 plus 25.12 equals, take away 30. The final answer is 43.12 square meters of surface area.